I'm going to introduce Dr. Leo Lagos, who will present our speaker. Dr. Leo Lagos is our Director of Research here at Florida International University. He is also the PI for the DOE Department Corporate Agreement. He's also the Director for our DOE FIU Science and Technology Workforce Development, also known as the DOE Fellows, and he's also a professor for the Department of Civil and Environmental Engineering. Dr. Lagos, you have the floor. Thank you very much for joining us, guys.
Thank you, Walter. Hopefully you can hear me well. It's a pleasure to introduce my colleague, István Szőke. He has many titles, so I'll go through some of those titles, and I think you see some of those, the work that he does in his background. But super busy guy, and from the energy technology, the Institute of Energy Technology in Halden, Norway. So István is the head of research for the DECOM cluster for decommissioning and repurposing of facilities. He's also the technical leader for the IAEA designated International Collaborating Center. There are 5 centers, I believe. Norway and IFE is one of the collaborating centers. He's also the initiator of the DG-DECOM, a great workshop and training series that has international participation. And that meeting happens yearly, and it's always a pleasure to contribute, to collaborate to that. And also responsible for Hydron, and I'm sure István will let us know what Hydron is as part of his presentation. So it's a pleasure and an honor to introduce István. He has been to FIU, and likewise I've been to Halden, and there's a lot of synergistic research that both of our institutions are doing, and we constantly are working with each other. So István, I'll give you the floor. Again, you're the first international presenter for the Tech Talk series, so no pressure. But again, it's a pleasure to have you and have that international perspective as part of this forum that we call Tech Talks, where we try to bring together the decommissioning industry experts from across the world now with your presence. And it's great to hear what you guys are doing at Halden. All right, I'll turn it over to you, István.
Thank you very much, Leo and Walter and everyone for the invitation. Really no pressure at all, right? Being the first speaker, and it's good that only found out now, so I only worry about it right now. But it definitely feels a great honor to speak here. So I'll try to share my screen again. We tested it before we started the recording. Hopefully it still works. Okay, I see nodding, so it still works. Thank you very much. So I'll talk a little bit about international perspective on decommissioning, and I just made a bit of specification in the title that my focus will be on 3D hazard aware digitalization and robotics, and these kind of technologies, transformation of how we look at the nuclear industry and specifically decommissioning using these technologies. This has been my focus on the last many years that I've been working at IFE here in Norway. This is the only slide that I have about IFE, just a very quick introduction. IFE has been in the nuclear game for very early on in 1959. This is a picture of the Halden boiling water reactor that was open in this state that you see in the picture. But also you see this colorful picture here, which is one of the first that IFE produced in terms of digital concepts, and in this case, VR, at actually augmented reality AR application for visualizing radiation in the Halden reactor hall. And then Halden has been hosting the Halden reactor project, which was named, of course, after the Halden reactor, which is to date the longest nuclear undertaking under the auspices of the Nuclear Energy Agency. And it was in 2018 when we also joined the other countries in the nuclear decommissioning game. And in the same year, we also got our designation as an IA collaborating center that was mentioned by Leo. And in this center, we were actually the first to get this in the field of nuclear decommissioning, and our focus is on digital concepts for supporting knowledge management in nuclear decommissioning. And then today we are continuing with this center. We also established the decommissioning cluster for decom cluster for decommissioning repurposing that I will present you in just a bit. We are running the Halden HTO project, Human Technology Organization project, which is a side project which born as a side project in the Halden reactor project, and it got bigger and bigger, and now it's in a way it's taken over for the Halden reactor project, and it has a bit more focus on digital systems and in human factors, and but overall it's still about safety and security for the operation of nuclear power plants. And we also established recently our lab called Hadron that is dedicated to AI data and robotics-based transformation of industries, which is I will also talk about. So since we are talking about international perspectives and trends, first of all, and I will talk about these trends a little bit, but I would like to just show that what are those sources of information that why we know about these trends. So I did mention the Halden Reactor project and the Halden H2 project, which are very large undertakings under auspices on the Nuclear Energy Agency. We have also conducted some surveys in the Nordic Nuclear Research, NGS. And Leo mentioned the DGD conference that we are running every year, where we always have some sessions where we talk about where is the innovation need and opportunities with specific focus on digitalization and robotics. We are running programs under the Nuclear Action Plan, which is government-supported programs to increase safety and security abroad, including in Ukraine, previously in Russia as well, which are now on hold, and some other countries as well. We are working together with Norwegian Nuclear Decommissioning, which is the governmental body overseeing decommissioning in Norway. And in addition, there's quite a lot of Euratom projects, which you probably may have heard about, the Share, the Pleiades, the Predis, and the Harpers. These are relatively large projects financed under the Euratom program. And each of these projects did some kind of actions to look at what are the needs and opportunities when it comes to innovation of nuclear decommissioning and nuclear backend. And finally, I would also mention the EGRS group, which is the expert group on robotics and remote systems under the NEA, where Leo is also involved. So these were the trends that came out from some of these projects, which is getting outdated now, luckily. Potentially, we had a little bit to do with that, and a lot of other organizations who are facilitating the emergence and application of innovative concepts. But before, it was a bit more special situations where this kind of digital concepts, robotics were applied, were a little bit constrained to special situations where safety critical jobs, like in nuclear power plants, more at the active areas and accident sites and more legacy sites with more increased hazards. Fleet decommissioning was also an important trend, and it still is. We do see that there's a lot more investment in application of robotics and digitalization in larger organizations where they see that these systems will be able to reuse them in several places, several reactors. But also newcomer organizations are quite interested in these innovative concepts because they see that it could help them do things safer. So as I said, it was a little bit before, and this is something that is changing. It was a bit more specific objectives for specific tasks where we saw that digital concepts were applied mostly. One of the most prominent application was facility configuration management, and this is where we started talking about the BIM, building information management, building information management concepts, and later that at the IEA we are also using the name PIM, plant information management. And there's an increasing number of examples which are looking more into integrated solutions. So I do see that the movement away from these really big solutions, some of the big companies offering these all-purpose solutions, including 3D model-based, BIM-based solutions that will do everything for you. But there's some international trend now to go away from those and establish modular concepts where different modules can be offered by different vendors, different organizations, and then basically the trend is to make these different modules talk together. And there's more and more interest in combining all these technologies, combining digital concepts with concepts that ensure safe and risk analysis, and also robotics. And this is how we established our lab called Hadron. And in all of these surveys, including the largest one that was done in the SHARE project, digitalization robotics were two very outstanding trends. They were always rated very high by the industry and all the scientific community, and especially some of the keywords were again related to integrated modular solutions, holistic concepts, and BIM, building information management related knowledge-centric plant information models. And when it comes to robotics, modularity is also a keyword, looking into modular concepts, and also multi-purpose ecosystems, soft compliant robots, natural telepresence, and intelligent systems. And then it includes all of these fancy keywords, digital twins, ontologies, robotics, AI, and so on. And it very much relates to the Horizon Europe's program called AI Digitalization Robotics. This is just a little bit about the Halden Reactor project, which is now in a way continuing in the Halden HTO, Human Technology Organization project. And the reason why I'm presenting this, that this was always following the trend, the way we were establishing research proposals or research activities was that we sent out invitations, we sent out proposals to all our member organizations, and then they said, what are those things that they would like us to do research on? And obviously those were the areas that were emerging trends. So we started from 2018 to 20 about safety management and training. And you see here that training is and has been a very important trend when it comes to digitalization, especially VR 3D based training for safety critical hazardous jobs. And also how to use this kind of digital concept for increasing safety. And then in 2021-23, which is the ongoing current program, the members felt that, okay, we did look at in general perspective about these two. Now we have to go a bit deeper about if you do training, how do we actually represent the information in 3D? So now we are doing research into spatial computing, AR for hazard mapping and visualization, and also how to automate the assessment of the performance of the trainees in the simulated virtual reality-based training systems. But in the same time, some of the partners, some of the members of the Halden Reactor project and the Halden HTO project said that we should still not forget about the holistic approach, take one step back and look at how these robotics and digital systems should be integrated into the overall capabilities for doing decommissioning. And then this hopefully should be quite in line with some of the trends, future trends. These are the topics that we were proposing to the members of the Halden HTO project. And then as you see, we'll look into sustainability as well in terms of decommissioning, but also go beyond decommissioning and look at the whole life cycle, how to manage the whole life cycle of nuclear assets, where decommissioning is one part of it. And then under this bigger chapter, we had 4 proposals looking into a digitized approach to circular economy, basically how to use all these innovative solutions for enabling circular economy approach. Also how to use digital twins, this kind of advanced physics and AI-based digital twins, both for safety and legacy management of existing sites that we are decommissioning, but also for supporting the design and the commissioning of newer sites. And finally, how to take advantage of all these robotics, digitalization, and AI, and what have you, for improving the regulatory process, supporting that, but also looking at the connection in the other way around, how the regulatory process should adopt in order to allow the application of these innovative concepts. So basically, if anyone is interested in these topics, then it's each member organization have a representative to the Halden reactor or to the Halden HTO project. And then it's very important that people reach out to them, because they will determine if these projects will start up from 2014 or not. 2024, sorry. And then overall, these were some of the very important keywords that are really related to the international trends for innovation of nuclear decommissioning, modularity and technology integration. So I had talked quite a lot about modularity, and I will show you some examples. And we also realized that there's quite a lot of technologies, both on the robotics side and the digitalization side, including AI and so on. And alone, they already make a lot of impact on improving the processes, but there's less work done on how to integrate these technologies together and then look into the business case from the integration of all these technologies. Standardization, harmonization is two very important keywords, because standardization is also very much related to this. If we want to integrate technologies, then we need some kind of standards of how to do that. And harmonization is also very important, because a lot of countries are working on innovative concepts. A lot of countries face the same problems, but because of the lack of harmonization, it's very difficult to join forces in development of these innovative technologies, but also to take advantage of the new opportunities across borders. Safety and security assurance is very important. We do realize that a lot of technologies developed outside of the nuclear, which are very much applicable, but because of our special circumstances in the nuclear, we need to make sure that we assure safety and we prove the applicability of these before application in the nuclear industry and in decommissioning. And it's very similar with the verification and validation. We do realize that the nuclear and decommissioning is a more traditional area, and every time we want to introduce new technology, we really have to prove that, okay, these are working. People want to apply things that are already tested. The holistic approach is very important in the nuclear and nuclear decommissioning, seeing that there's a lot of actors working together, and it's not just a technology problem, the decommissioning. It's very important to look at introduction of these new technologies from a holistic perspective, considering both human technology, but also organizational aspects. Very important to be very clear about the value proposition, about the value of the digitalization and robotics, because that's the only real way to convince the people who are actually in charge of investing into innovative concepts, because they need to, then we need to prove, how they provide value. Collaboration, of course, it's a never-ending story. It's very important. There's quite a lot of parallel developments. And competence. Of course, we really make sure that the new generation is ready to use these new technologies. So now I will go and just, rather than say a lot more about these keywords that I will repeat on some of the slides, I will just show you some examples how we are trying to address these important keywords that we think has a large impact on innovation for nuclear decommissioning. So I'm going to talk a little bit about the Hadron. This is the new lab, stands for Hazard Aware Digitalization and Robotics in Nuclear and Other Domains. And from the name, you see that we realize that a lot of these concepts that we were started to develop in the nuclear and for decommissioning are very much applicable. And basically, they are not so much specific to nuclear or decommissioning, but they are more specific to safety critical and hazardous environments. So hence we extended our focus. And the Hadron lab will support our IEA collaborating center. It is basically a technology backbone for the cluster that I mentioned, very much related to our workshops and the training series. And of course, we'll also support the research in the Halden HTO and the Halden Reactor Project program. So very simply said, Hadron is about how to integrate the innovative robotics solutions with the 3D digital concepts, how to integrate these with 3D hazard modeling that makes these digital and robotics concepts applicable and verified for safety critical applications and hazardous environments, for instance, like nuclear. In the background, you see a picture of 3D dose picture from Fukushima. And then we realized that Hadron, these concepts will be applicable to nuclear decommissioning, but also maintenance and decommissioning in other nuclear and other industrial installations. Incident response in situations where there could be some kind of hazards, could be nuclear or could be CBRN, radiological, chemical, and other labs, space applications, and basically any type of work where we are handling dangerous substances. And by default, you see, since we're looking at all these application areas and the integration of these technologies, we are very much addressing modularity, technology integration, and collaboration between all these industrial areas. When it comes to digitalization, this is some of the big digital trends that we are looking at. You see, some of them are things that we do ourselves at IFE as well, and then some of the things are technologies and developments that are done by others. And here we are looking forward to get partnerships. So of course, XR, extended reality, which we talked about virtual reality and augmented reality, and now we talk about XR, which is a whole range of different levels from the real to the completely virtual. We are talking about building information management and GIS, geographical information systems, and integration of these. We have been working with 3D scenario simulation, simulating processes for maintenance and decommissioning in the nuclear with radiological modeling, machine learning, and AI. And ultimately, this culminates in the 3D digital twins that combines the BIM concept, the scenario simulations, machine learning, AI, and XR into something that we call advanced digital twins that can be, or hybrid digital twins that can be supported both by physics modeling and by AI. And on the sideline, we have the 3D hazard mapping, which provides the input for these innovative concepts. We have semantic information systems that are fueling information systems like Wikipedia, for instance. Safety argumentation, I'm going to talk about that. Costing and innovative project management tools. So on the XR, extended reality front, very important thing that we have been doing the longest probably to make these XR applications applicable for nuclear decommissioning and nuclear in general is to combine them with a library of radiological modules that is capable of analyzing the radiological risk and visualizing the results in an easy to understand way, for instance, visualizing radiation for the people. The platform that we are using here, we call VRDOS. This is a platform that is a BIM-based, 3D modeling-based platform, integrated radiological risk assessments, the modules that I just presented, and you can use it for visualizing, optimizing processes, demonstrating, documenting these, and also taking this information to the field or training people in VR before going to the environments. There were several projects, several sites since 1999. We have actually been working quite a lot with Russian sites, especially since they were very close to the Norwegian border, and these were sites that were not in a very good shape. We have been working and still working with Ukrainian sites, and we have been working with quite a lot of other sites as well. And of course, now we are also working quite a bit with the Norwegian problems. Ultimately, these projects were about 3D information management, establishing visitor centers, training centers, systems for ARARA principles, and training simulators. And then what we had been starting to work at is how to integrate all these different concepts, because we did realize that, yes, XR is very important. People really want to apply those. BIM technologies are very important. Radiological risk assessments are very important. But ultimately, what people want is a more integrated capability rather than thinking about all these things separately and then think about how to integrate these. So we looked at a holistic approach from a functional perspective. And I looked at what are those key capabilities that you need to work together for supporting a nuclear decommissioning project. And then this is the result that we came up with, including costing, project management, facility configuration management, and so on. And then we translated it into data system perspective, and we said, okay, for facility configuration management, then you typically use the 3D modeling and the BIM models. For the planning, you can use job planning systems, you can use project management systems and costing system for the costing, and these all should be able to work together because you need all of these functions. And for instance, project management, would have to have a lot of input from the facility configuration management for the work planning and so on. So basically, these systems have to be able to communicate with each other. And the input to these systems, this was actually something that we realized quite early on, that, yeah, these systems, once they are up and running, they are great. But how do you establish this system? How do you make sure that you have all the 3D data, the input that are required to establish these systems? And then, of course, there has been a lot of advances in systems like 3D LiDAR scanning, but also there are systems like this one that we have been working quite a lot with from Createch, where the 3D laser scanning is combined with gamma scanning as well, and thereby it can emulate the functionality of a gamma scanner, but also represent that directly provide information in a 3D. So basically, it provides with the 3D model we attributed with those or activity values. And then, okay, what we said is that if you have that input from these systems like the one from Createch, then you can integrate these with systems like the RODPIM, which we created at IFE for radiological characterization, the VRDOS that can simulate decommissioning waste management scenarios, the simulation editor, which then can turn these scenarios into interactive training modules, and additional modules like the Instruct and the Colaris for risk management and for safety demonstration and argumentation. And then of course, in the core of these is the BIM concept, which we did, and there's a lot of tools already on the market for building information management, and rather than replicating these, what we said is we take advantage of those that are existing in the market. For instance, the BIMsync system that is developed in Norway, or the VIRCOR system that is developed in Spain. And then we build around those rather than repeating the BIM technology. We extended the BIM technology by all of these functions that are required for the nuclear industry and specific for decommissioning, and thereby achieving an open BIM compliant system that follows the open BIM IFC standards, thereby making it compatible with any other systems that follow the same standard. So this is how the architecture for this integrated system looks like, taking input from LiDAR and 3D gamma scanning systems, but also any kind of characterization data. These are typically point clouds or activity point clouds. It goes into a point cloud tool, converting it into the right format so that you can use it for characterization, risk information management, planning, and training. And then each of these, the output of each of these tools goes into a converter that stores the results in IFC, in an IFC database, in an IFC format, thereby making it in a standard format. And then the front end to this would be a BIM tool, a federated BIM that allows the user to have a look at all of these entrances here, the point clouds, the radiological properties, the risks, an overview of risk, and so on, all of these in an IFC format. And then also this can be combined with historical, radiological, and other databases and MRO systems. One project that specifically looked at some aspects of this was the PLOG project. Here what we did is we converted 3D models that were achieved through 3D scanning into IFC models. We did the same with radiological visualization. So here you see radiological visualization in this one layer. Here you see that the yellow is high radiation, and then the more purple blue is the lower radiation. But this is now converted into IFC format. The same with the activity point cloud. And also here we tested out how to segment this IFC point cloud converted in IFC format without having to turn it into a full-scale BIM model. So we worked quite a lot more about what you can do with 3D point clouds, and what you see here is very high quality, but it has been produced by a high-resolution laser scanner. This is from one of our nuclear sites here in Halden. How you can use these kind of point clouds directly without having to prepare and put a lot of work in preparing a CAD type 3D model for risk information management. And this is the concept that we developed at IFE for the transport industry, and now we are adopting it for the nuclear decommissioning. We have a risk log on the left side, and these are stored in this SHA format, security, health, and work environment, and then that you can attach to different points and different components in this 3D point cloud. And then they all can be associated with risk reducing actions. And then you can go through the risks that are recorded for certain points, environments, and components. And then you can manage the actions that would be in response to these risks in a 3D format that only uses a 3D point cloud as an input. We have been working from quite early on about safety cases. So safety cases is basically just a structured way of demonstrating safety. Typically, you have this kind of PDF or Word, whatever type documents that are describing what are your assumptions, what are your arguments about why the work that you are doing is safe, and what are your evidences that this is true. And of course, it's in this kind of linear format, it's not so easy to follow. So what we try to see is, can you convert it into a more graphical format where you see the decomposition of this argumentation from high-level arguments to lower-level sub-arguments, and then from each of these arguments, then you have connected evidences, and also comments, so that you can follow through this tree for your whole argumentation process. Each of these nodes can be connected to a certain paragraph or a certain part of the text in one document or another document. So thereby you can actually use this concept as a document management system with a specific way of organizing information, and this in this case related to safety argumentation. And then each of the nodes, then we also prototyped here that could be connected to a certain point or a certain time and a certain component in a 3D model of your facility. So thereby you have this three-way thing where from the model you can navigate to your documents, and from the documents you can navigate to your argumentation tree and back and forth. And thereby when you're preparing your safety case, you can start with this kind of skeleton, having your model, and then prepare your full scope description, or vice versa. You have your description, and you can use this, both the model and the graphical argumentation, to update and modify it in case there's any deviations. And this is an ontology. This is basically a way of organizing your information. So in the Pleiades project, which is a European Commission financed project, we looked much deeper into ontologies. We looked much deeper into what should be a standard way for organizing knowledge and information in the nuclear industry, with a specific focus on nuclear decommissioning and other large projects like nuclear decommissioning. This was one of the first steps in this project, and this is kind of just one picture, and there's all of these categories that you see here with a larger frame around them. They have subcategories, but otherwise this is the top level ontology that we ended up with, and this is something that we would like to propose in collaboration with the International Atomic Energy Agency as an international ontology for representing nuclear information related to any nuclear projects. And then you have all these high-level categories of decisions and costs, and you have the subcategories for at least these. And then, of course, they can be further further subcategories. And then what you see here is that, again, rather than reinventing the wheel, we have HSCs that are components in a facility that can be very nicely represented in IFC, in BIM, the standard BIM format. And rather than reinventing that, we are building around these, adding all those categories that are not necessarily represented or not in the way that it should be represented for the nuclear industry. One important activity where we would like to take advantage of this international ontology is the technical working group on new and emerging technologies to advance decommissioning projects, where Leo is also a member, so we're working together here as well. There's a subgroup called Management of Legacy Data, where one of the challenges that we are trying to look at is that there's a lot of information, of course, when it comes to nuclear decommissioning. It's not so much the problem many times, not about lack of data, but there's all these different data in the different formats, and then it's very, very difficult to see what is your essential data, what is that you should really focus on because you need it for the decommissioning. How to extract that essential data set from all this sea of different documents in different formats. And then basically the mandate of this group is to investigate current and emerging tactics for composing an essential data set that is correct, complete, and structured by analyzing and mining information for legacy information that is useful for decommissioning. So here, natural language processing, for instance, would be a very important tool that we would like to use. But then, as you see, this would be very heavy about structuring information. And since the Pleiades project is already proposed an international way of structuring information, then we would like to follow that structure here. Another very important activity which continues in the same project, the Pleiades project, we would like to then aims at taking advantage of this standardized information data structure for integrating modern decommissioning support tools. So here from IFE, we have the ROTBIM and the VRDOS that are characterization and work planning tools. We have additional systems like Aquila Costing from Slovakia, which is an ISDC-based, is the only ISDC-based proper client tool. We have the BIMsync, and we have the IUS IMS semantic tool that together can provide a more integrated support. But we also have other tools. Some of them have overlaps, like the iDrop Damplas from France, for instance, and so on. And the whole point of the project is that it's no longer about having necessarily one tool for one thing. You could have different tools. They have strengths and weaknesses. And the point, one of the very important point of the project is that you don't necessarily have to choose. You can use these tools in parallel once they are integrated and they're able to exchange information seamlessly. And of course, this project is very about modularity, integrating the technologies. It will use a standardized process, so it will also support harmonization. The project now will be in the phase of testing this concept out and describing what's the value from this. And also, there's a work package here on competence, so that basically training for how to use these kind of innovative approaches. There's a lot of people involved in this project. IFE is one of the members. It's led by CA from France. And then, of course, there was a lot of work, actually much more work than the development of the ontology itself, about how to turn this ontology into something technical, into something that can actually create a server, a central server, where all the tools can tap in and exchange data. And then this, since the data is actually very in different formats, because then from radiological measurements and material properties, you have all the way down to point clouds and scenarios and safety cases. Then it was a big challenge about how to represent this data in a more common way so that all these different tools can take advantage of the same data pool. Another very important project here is the PREDIS project, which focuses on predisposal of radioactive waste. It's somewhere in between the Pleiades and the FIU-ARC project, where FIU-ARC focuses on disposal, Pleiades focuses on decommissioning, while PREDIS focusing on what happens in between. And a very important task for IFE was to develop a decision platform supporting the pre-disposal management of radioactive wastes. This slide shows a little bit about the current state of our development, where from where real-time data from sensors that can be embedded or attached to waste packages, but also static metadata that can come from, for instance, BIM-based models of waste management facilities and waste packages. How this data can be integrated, and of course, there's a lot of steps here through message brokers and tools that can translate this data into something that can be represented in a common database, where all the static data and real-time data from sensors can be aggregated and then presented in a graphical format, and also support that can be connected to the decision platform, because ultimately, based on this data, and you see down here some examples how this data is will be represented at the end, should support your decisions about waste predisposal activities. It was a very important challenge here, while it was very easy to see the potential in this project. It was not very easy, and it's still not very easy to actually see what are those concrete requirements that the waste producers would like to get out of such a system, because it's very innovative. So this project will be presented in detail on the Waste Management Symposium in Phoenix this year by Reka, who I think is in the meeting with us. This slide just shows a little bit about how this kind of digital concepts that are based on 3D scanning, representation of emotion in BIM systems, integrated with costing systems and semantic system, could support circular economy approaches. Typically, this kind of information can be used for waste routing, where you have the source, which in this case is represented in BIM systems, supported by characterization tools, and then go down to different routes until they are disposed. But then factoring in the circular economy approaches, then this picture becomes even more complex, because some of these endpoints, before we were always thinking about this endpoint as a disposal, we should be thinking more about these endpoints as a potential for reuse and valorization. But of course, in order to do that, you need a lot more data, and your picture here becomes much more complex, because there's a lot more different ways, a lot more variations of what to do with your waste. So then the potential in application of AI-based optimization algorithms becomes much, much higher. Since I talked quite a lot about standards harmonization, one very important project that I would like to mention is the Harpers, which was one of the most recent projects that was started. This is the only project in the current ongoing Euratom program, in the last Euratom call that was that was referring to decommissioning and waste management. And this is about harmonizing harmonized processes and regulation standards in waste management and decommissioning. The starting point of the project was the different national regulations that hinder broader markets, and this is something that I mentioned in the beginning. The slow adoption of new technologies, for instance, due to the regulatory differences between the different countries. There's low use of recycling for the same reason, and there's a risk of negative public perception related to environmental sustainability issues. And the project is aiming at addressing these issues and establishing, clarifying the benefits and added value for more aligned and harmonized regulation practices standards in decommissioning and waste management, but also identify obstacles and issues preventing implementation of more common regulatory framework. Ultimately, of course, the project would enhance the overall safety and economics of the nuclear sector. So this project actually does quite a lot of things that this project will address. It will address, of course, the harmonization and the difference between the regulatory processes and processes in general between countries. And it will also have quite a lot of focus on how application of innovative technologies, digitization, robotics, can play an important role, and also how the innovations that we are seeing now can give rise to more to higher use of circular economy. This project will also be presented by Reka on the Waste Management Symposia this year, so there will be a lot more details provided for the project on that event. Now I will talk a bit more about the robotics. On the Hadron side, in our lab, we are looking into how to integrate these digital concepts with robotic concepts. And the reason why we ended up looking into robotics is that, as I indicated in the beginning, we always had very positive feedback from the application of the digital concepts. And the biggest obstacle was always about how you get input from the environment for these concepts and how you take the result of this concept into the environment. And then robotics, and especially mobile robotics, drones and different quadrupeds and so on, that can nowadays, like this quadruped here from Boston Dynamics, we have one of these. It can navigate rougher terrain, and it can actually take sensors and manipulators into more harder to access environments. And you have different types of drones that can be applied in a nuclear and can take sensors. And then I always use this example that I stole from Leo about small robots that can crawl into pipes and magnetically adhere to tanks and go into places where no other robots could really go. But we also see that there's more and more about humanoids even appearing, and more applications. We have been working with this humanoid and another one actually in our projects, but also the larger systems and that can operate higher payload and can lift things much higher. They have a place. So ultimately, this is what Hadron is about. I've been talking about digital concepts where you can use digital twins of these robotic assets. You can analyze your requirements and break down your argumentation. You have 3D models of the environment and your hazards, and you have the work processes, ultimately supporting an AI-powered digital platform. But this platform can get a lot of input from robotic systems, but also can provide a lot of support in terms of support for design, support for training, but also for evaluating the efficiency and feasibility of these systems in specific environments like the nuclear environments. And one important project that we are running here is the RoboDecom project, where we are integrating mobile robotic platforms with 3D scanning, gamma scanning platforms, and with all these digital concepts that I've been talking about. And then just recently, we actually signed an MOU with the company Createch, where IFN Createch. Our aim is to establish a new company, so that this kind of integration gets to a higher TRL level and gets access to the market. And in this picture, hopefully they started moving, I hope. This was actually the first time when we took spot into the Halden reactor, and and you see here the point cloud that is being generated by the sensors on the spot. This had to be done on a very short notice, so actually we not have time to put all the sensors on the spot, and this was actually one of the very, very first demos. And then we did a lot more focusing on 3D scanning and how to use this digital concept for electromagnetism, basically the radio signal mapping for robotics, radiation mapping and sampling and so on. And we used both spot, but also some other smaller four-wheeler platforms and a bigger platform from a Norwegian robot supplier. And ultimately, this is where we would like to end up. We have all these robotics fueling this kind of 3D digital twin and AI-powered physics and AI-powered digital twin systems, where you can plan your work, you can analyze safety, and do your characterization and so on. So we have this 3D ecosystem combining all these ingredients that ultimately result in this integrated system. So we do this research in collaboration with the IEA, and we got this plaque in 2018. And we also established the DECOM cluster. And here you see IEA and our Minister of Commerce here, and NND helping us inaugurate this center. And this cluster is getting more and more participants, and we are looking for more. And one very important thing is actually piloting, do just pilot projects together and collaborate and make sure that this innovative concept can be applied as soon as possible. And one very important thing that we are doing both in the IEA Center and this cluster is use, well, the one very important natural output of using digital concepts is that you have your facility configuration, you have your radiological data and your processes in a very easy to visualize format. Thereby, it's very easy to turn them into interactive training material. Like this, you see some examples that we used in our last training course, which was done on the Linder initiative. This one is from Fukushima. And then we use this to teach concepts, how to locate radiological sources. You could take environment into radiological environments without them having to be exposed to radiation. This is from our reactor and teaching different waste management principles and so on. We are preparing our new training course now, the DigiDecom training that we would like to organize this year under the IEA Center. So if anyone's interested, then please tell me. And as you see here, we have earlier we had the Argonne National Laboratory and FIU as partners in organizing these courses. We hope we can do the same for the next course. We're also establishing a national center on nuclear now, where this kind of XR-based training concepts will be addressed. And I think this is one of the last slides. This is an invitation. EURAD and the previous project together, we are inviting people to provide opinion papers. I am one of the editors here, so if anyone is interested, I can also put you in contact with the other editors here. And one very important thing that we're looking at how to apply these digital concepts. There's a lot more going on the decommissioning side than on the disposal side. So one thing, this is exactly why we chose the Environmental Earth Sciences journal, because we would like to see a lot more happening here on the geological disposal side, where application of BIM concepts has to be integrated with geographic information systems, and the application of these is not as straightforward than in decommissioning. And this is my final slide. This is our annual decommissioning workshop called DigiDecom. It has been generalized from the beginning. It was focusing only on nuclear decommissioning. It's getting more and more integrated with decommissioning in other industries like the oil and gas, but the main focus is still in the nuclear. Has been going in 2017, and next year will be the first year when we are actually going away from Norway, and we'll be organizing this in Finland, but we'll also be part of an online event. So you have a QR code here, which will take you to the free sign-up page. I know that Leo has been with us in some of these workshops, so we hope that we'll have a good collaboration this year as well with FIU. Thank you very much. I'm a little bit over time, I see, but not. Hopefully that's okay.
No, István, great presentation. So I know the pressure was on at the beginning as our first international speaker for the Tech Talk series, but it was a amazing presentation as always, right? The work that your group does and Helden is pushing the envelope for innovation when it comes to decommissioning. So kudos to you guys. I just wanted to, before we open it for questions,
thank you, Leo.
Wanted to recognize the participation of our colleagues at DOE headquarters in Washington, D.C. So we have Nancy Bushman, Jennifer McCluskey, and J.P. Pavon. I think he was on the call. So thank you for participating, as well as our executive director, Dr. Triay. So I'll just move out of the way so they can recognize Dr. Triay as well. And you mentioned Rika Szőke, our other colleague from Norway, from Halden. So Rika, thank you for participating as well. We'll see you at Waste Management. So with that, as I said, more than a question, it's just a comment how again, you're pushing the envelope for innovation, digitalization, robotics, and again, that's what will take, to complete the mission, right, across the world in terms of decommissioning. So all those new technologies will be needed, including artificial intelligence. So kudos again to your team. So I wanted to just open it for any questions that you may have for Dr. Szőke. We open the floor now, so feel free to raise your hand if you are online or here in the room, if anybody has a question for István. Okay, we have one hand raised here, our executive director, Dr. Triay. So Dr. Triay.
Excellent presentation. I truly enjoyed it and learned a lot from it. With respect to the view graph that you had on regulation and how that sometimes hinders, the progress, which is something that in the nuclear field we understand well. Is there any ability, movement towards making the regulations more standardized across the world, in other words, internationally? I know that the regulators, are local regulators, like we have in the United States. It even varies from state to state, even within the United States. But is there something that the IAEA or another organization that is more international is interested in doing, and working with groups like your group, like Leo's group, to try to make this more standardized so that we don't waste so many resources in trying to negotiate at the very local level, so that to minimize those kinds of negotiations at the end?
Yeah. Thank you for the question. Well, the answer is yes, and I would say that while there's a lot of separate initiatives, the most important was actually the Harper's that I presented. Reika is actually the technical manager for that project, who is with us in the meeting, and that's exactly one of the main aspects of that project, to look at the value of harmonizing. And if I understand it correctly, Reika could correct me here, it would be very difficult to standardize and harmonize the regulation itself, the regulations are based on the safety standards. So if we are able to harmonize those, how the safety standards are interpreted and how they're used in the different countries, then maybe the regulations could be still different a little bit, but they are based on the safety standards that are understood in a similar way, and thereby it would enable us to think about waste management more across borders rather than as we are doing it right now. And also the technologies that we are developing in the different countries would be a lot more transferable from one country to the other, because once we understand we have some kind of more standardized process about validate technologies and make sure that they are confirming regulations, and those are similar in the countries, then you can just take these technologies from one country to the other. And that could include circular economy principle, which is probably one of the most difficult ones. For example, in Europe, we have a big difference between how freely this can be done in France and how freely that can be done in another country, and that would really very enable us to work together. But I would also just one other comment here is that this project would look at, and also some of the proposals that we have in the Holden H2O project would look at this both ways. One of them is how the regulation should adopt, so to say, but also how the regulation could take advantage of these new technologies. Because in many times it's not so much about we want to change the regulation, but we want to innovate the regulation. We want to make sure that the regulators can take advantage of these new technologies, and then they can have basically a lot more information. They can have a lot more understanding of our safety case than before, and then pushing in innovative technologies thereby could become much more easier, because it would be much more easy to show the regulators what we are trying to do. I'm not sure if it answered in any way your question, but
Oh, it was perfect, and it appears to me also that the approach, that if I understood you correctly, of they standardize the safety features, and then that would mean, that the regulatory review will go a lot faster, across the world, really. No, that's thank you very much.
Yeah, perfect.
Thank you.
Thank you. Walter, I know we have somebody that raised their hand.
Yeah, we have a question from Brandon Sintas.
Yeah, I wanted to give an opportunity for Nancy. I'm not sure, Nancy, if you want to say a few words from the DOE perspective.
Thank you. I don't have anything to add right now. Thank you.
All right, no, not a problem. Walter, if you want to, or Brandon, you have your hand raised. So Brandon, if you have a question, go ahead.
Hello, thank you for the very interesting presentation. Can you guys hear me just fine?
I can hear you.
Perfect. Okay. So I'm very impressed by some of the point cloud usage for trainings and simulations. But would you be able to talk a little bit more about the limitations when you're actually in the VR space?
Limitations in terms of what?
So in terms of sort of like the visibility of some of the more finer features that are within the actual site versus the digital version of the site?
Yeah, absolutely. So first of all, what I think I show you some examples of point clouds here, and you may have noticed that some of those were like really rough, because we did them in a very early state, and we did them with a much cheaper scanner. So that's also one very important aspect to recognize, that now some of the scanners, and they are not crazy expensive, the resolution of them is so high now that it's, at first glance you can't even notice, it's not a 3D picture. And even if you go relatively close, then you have a very high resolution. So that's one thing that is very important to recognize. Of course, your data set will be much higher. And the other thing that is very important to realize is that we were always, at least so far, we're always thinking about, is it a 3D model, or is it a point cloud, or is it a 3D photo that I should use? And now it's very important that we don't have to think about these things individually. We can combine point clouds with CAD models and the 360 photos. So depending on what you want to achieve, you can actually combine. You can use a point cloud if you actually need to measure things and you really need a 3D, but you can also switch to a 360 photo when you want to see the finer features and not necessarily measure something. And the combination of this is definitely possible. And also the resolution can change. So in some instances where in some areas you want to have the finer features because you really want to measure and see how it looks like. And in other situations, you just want to have a big picture. So you can combine a more lower resolution or even a very dummy 3D model with a more finer point cloud or a very high resolution picture. Does it answer your question?
Yes, it does. Thank you so much.
Are there any more questions from the audience?
Yeah, there's a question here in the room from Gabriel.
But you mentioned trying to standardize all this technology. There's some sort of repository or place where we can look up to see the standards that are currently in place or be developed.
Leo, can he get closer to the mic because it's hard to hear?
Yeah,
Or just repeat the question, Leo. And
he'll come over here. He just was looking for the repository for all the standards and technologies.
Yeah, that's the short version. I don't know if you can hear me better now, but you mentioned standardizing all this technology, and it all seems somewhat different to me. Is there some sort of repository where we could check on the standards that are currently being developed, or if there's ones that are already out there?
Standards. Well, when I talk to standards that were more about data standards, right? That's one very important thing that we are trying to do here in some of the EU projects to standardize how data is represented. Because then, if you have that, then you can exchange data, and also it's very much related to the regulations as well. If you call things the same way, then you can actually build up your safety argumentation. You can and your regulatory process in a standardized way. Yeah, and in that sense, we do in the Pleiades project, of course, those results are ready and they're online, so you can have a look at what is the standard that we are proposing, but that's a very high level. In terms of the technical realization of these, which is not straightforward, at the moment there's no standard. We did realize that it's not straightforward how to implement a high-level ontology into a technical implementation of a data architecture. And there, I think it will still take some time to come up with a standard because we are just figuring out how to actually realize this. Or did your question refer to something else when it comes to standardization?
No, that sounds right. So from my understanding is you're not trying to standardize how we collect data, just how we share it between everyone.
Yeah, exactly. But of course, when it comes to data, we do have in our proposal, we do have something called data, or we could have something called a measurement, which has a lot of characteristics where you can actually define what is the quality of the data that you would require. So that would also be standardized. Thereby, you can really use it for data quality objectives in a similar way.
I have another somewhat not so technical question, but you've shown us a lot of technologies here. Which one do you think, or which one of these would be your favorite or you're most excited to see be implemented?
Actually, the most excited part of it is the integration of these, and this is exactly one big thing that I'm always trying to emphasize. Some people are working with AI, some people are working with robotics, some people are working with safety demonstration, some people are working with human factors. The thing is that you need all of these, and until we realize that we have to address them in a common way, then the value proposition from each of these are going to be much lower. Because we can push all these fancy technologies if they are not tested right. We don't explain how to use them. We don't explain how to integrate them into the process. They don't really work. And again, when it comes to robotics and digitalization, individually they are much weaker. When we combine these two, then the robotics can provide the data, and digitalization can enable the robotics, and together they are much stronger. So to me, the exciting part is the integration of all of these.
That's fantastic. Thank you. Great presentation.
Well, that's very well said, István. If there are no more questions, I want to thank the audience for attending and thank you for making the time. István, thank you so much for your time. I appreciate you coming through and late notice. sounds like you're doing a lot of things, research that we are focusing here in ARC as well. We're doing stuff with machine learning and robotics as well. We have a very own spot. I don't know.
I
Did
know,
we name
I've
it
seen
yet,
them.
Leo? Did we name it yet, Leo? This our I don't
Yeah,
know if
yeah,
it-
we have we share that in social media, so I think there's a link to showing the spot robot.
yeah,
So
we had to give it a name.
cat is out the who let the dogs out, right? I think we already let the dogs out.
So I
Yeah,
guess
it's a very impressive lab that you have there. And we discussed with Leo many times that we should have a stronger collaboration because we are looking into robotics, but our main field is digitalization. So we, in the robotics side, we would really we want to work together with people like you guys.
Excellent. Thank you so much, István, and we'll see you soon.
so.
Thank you for the
Just
invitation.
to close real quick, for those that are still here, our next Tech Talk is April 18th, so mark your calendars. And if you want to be informed about this Tech Talk, or if you want to follow up with us as far as receiving notifications, you can sign up to our newsletter. You can find it on the web, on the chat that I posted separate things in the chat for the newsletters. Once again, thank you so much, István, for your talk. Very interesting, full of material. And this information is recorded and will be posted on our website as soon as it's all clear. Once again, thank you all for attending. See you next time.
Thank you, Walter.
Bye bye, everyone.
Bye.